All right, in this part we're going to take a close look at parabolas, and we're going to look at it in a way you probably never looked at it before. We're going to look at some things some properties you probably never examined, maybe you have a little bit, but we're going to take it a little bit deeper. So back early in chapter 2, we took a look at parabolas in general, kind of looked at their opening pattern, and that was probably about it. We didn't do a whole lot. We looked at the vertex, opening pattern, some of those properties. So we're going to define it a little better. So what I want you looking at is these two new things on here that we really haven't played with this year at all. One's called a focus, and the other one's called a directrix. Okay, and I'll have all these defined later on. Now, if I change the opening of this parabola, and I'll explain all this stuff later, and this is also on my website if you want to play around with this graph. So if I change the opening of the parabola, the wider the opening, the further away from the vertex this focus is. And there's some other properties I'm going to talk about a little bit later today too. Now, if I make the parabola more narrow, so I'm changing the opening pattern, the focus gets closer and closer to the vertex. Now pay attention to how far this directrix line is from the vertex and how far the focus is. All right, you should be noticing that they kind of mirror each other. And that's what's happening. They're exactly the same distance from the vertex. This is above it, this is below it. The focus is inside the parabola, directrix is kind of below the parabola, or outside of it. All right? Now the other thing to look at, as I start moving this point along the parabola, and I'm drawing these two lines inconveniently, but look at what's happening to these two lines. Think about what you notice about it. And if it looks like they're staying the same distance or same length, that's true, they are. And that's how we're going to define a parabola. So we're going to define it as, for any point on the parabola, it's going to be the same distance from that point to the focus and from that point to the directrix, or at least straight down to a tangent to it. So that's where we're going to begin. All right, so let's start putting some concrete things on here. First up, the vertex is HK. Now, parabola is unique because HK is the vertex of that shape. For every other shape we're going to do this section, it's the center point. So parabola is the vertex, everything else is the center point. Not a big thing to remember. You'll kind of get used to that anyway. And you're used to a vertex being the key point you begin with for a parabola anyway. That shouldn't be anything new. We've done it this year. You've done it in Algebra 2. So the other thing I'm going to add in is the focus and the directrix. And again, I'll formally define all that stuff soon. Well, the focus and the directrix, they're the exact same distance from the vertex. They're both the same distance, one's above, one's below. So this point is also H, but then it's K plus, and I'm going to call this distance here P. So it's this height K plus another distance P. And this part right here, this is the same distance P. But any point on that line, this is a horizontal line, so we need to define it that way. Horizontal line, we don't really care what the x-coordinate is, because it could be anything. But no matter what the x-coordinate is, what's our y-coordinate? And that's going to be this value K minus P. So relative to the vertex of the parabola, it's P below that. So there's the definition of that point. All right, let's put a point on the parabola. So some xy coordinate, and whatever this distance is to the focus from that point would be the same distance to the directrix below. So that's where we're going to begin deriving this thing. D1 is equal to D2. Right, so now the challenge is, let's define what D1 and D2 are. All right, well, D1, for the x-coordinate, you can think of a distance formula. But the x-coordinate, if you kind of made a little triangle here, it's going to be x minus h minus x, whichever you want to go. So I'm going to say x minus h squared. Plus change in y. So whatever it is from y to k plus p. So y minus k plus p squared. All right, so we'll put all that in parentheses and square it. And it's distance formula, so we're really taking the square root of all that. Now the second distance, well, you don't go over any at all left or right. You go directly down. So the change in x would be 0, so that's kind of nice. That makes that part easy. The change in y, well, it's whatever y minus this y coordinate down here, which is always k minus p. So k minus p, and then all of that is squared. And then we take the square root. Again, this is just distance formula. All right, now the square roots can go away because you can square both sides right now and make those square roots go away. So I'll go ahead and do that. The trickiest piece is going to be taking this y minus k plus p and this part here. That's going to be really the hardest part of this. So what I'll do is I'll ask you to try to expand that in just a moment, and then I'll kind of flash up here an organized way to do it so you can check your work, and then we'll move on from there. So again, I'm going to square both sides. That's going to make the square root go away. All right, this is going to be x minus h squared still. I'm not going to change that. There's really no reason I can't expand it. I know where it's going to end up, and it actually makes things more tricky if I try to expand it. So I'm going to keep it right there because really these are the parts that are going to define everything. All right, so next would be y minus k minus p squared. And over here, y minus k and then plus p squared. Okay. So what I'm going to ask you to do at this point, take a minute, expand these two parts out. They get a little lengthy. Keep this one the same. That'll make life a lot simpler for you. There's really no need in the end to expand this out. You can. It's not going to really give you an advantage. It just makes things more cluttered. So keep this the way it is, but expand these two out. I'll come back and we'll run through what it should look like, and we'll conclude the definition. So I made these little tables. I like this way to kind of organize doing a trinomial and squaring it. So here's y minus k plus p. Same thing down the side there. And you could certainly write the two trinomials beside each other and basically do extended FOIL. That's fine. Again, I just think this is a little more organized. So the way these work, if you haven't seen them before, it's just a multiplication table. So y times y is y squared. Y times k. And I would keep everything in alphabetical order so it's easy to know which terms combine. That just helps you organize things better as well. So minus, and we'll say ky, and then plus, we'll say py. Again, keep it in alphabetical order. Here would be minus ky. Here would be plus k squared. Here's minus kp. Here would be plus yp, or let's do py, keep it in alphabetical order. Minus kp, and then finally p squared. So the way you put everything together would be y squared plus k squared plus p squared. I'm just kind of going down that diagonal with the nice squared ones. You have minus 2ky. You have plus 2py. And then finally you have minus 2kp. All right, so try the other one on your own, and I'll come back and show you what it should be. All right, so now here are both tables completed. They're really the same thing except this one with minus k plus p, you have plus 2py minus 2kp. And just notice those two are the exact opposite over here. Everything else is exactly the same. So I'm going to go back to the definition we started. And I've already added these two in. And I think they were actually reversed from the way the tables were, but just be careful with that. X minus h squared I copied straight down. This I expanded into all that stuff. And it equals the other side. I had to run out of room, so I had to bring this down below. Keep everything kind of lined up on purpose, but when you expand this out, It's all this part, and that's from the table. So now let's start kind of thinking about what would happen. Now, just be careful. These are opposite sides of the equation. In class, I would do this across the board so we have plenty of room, kind of out of room on this part. But what to pay attention to? All right, well, if you have y squared on this side and y squared on that side, you would subtract y squared out of both. And there's, so let me do it that way. Minus y squared on both sides. So you see that subtract out. You can subtract k squared on both sides, and that will go away. All right, now, anything that's the same on both sides, you subtract it out and it's gone. So all this stuff, I put those together on purpose. All those things are now gone. So at this point, what I would do is keep x minus h squared over here. And I would move these two to the opposite side. So let's kind of show how that would go. That'd be plus 2py on both sides and minus 2kp on both sides. All right, I want to move it to the right. So it would be gone on the left side on both. On the right side now, 4py minus 2kp. We're getting close now. We want to solve this thing for y. So things in common, this will keep the same over here. Over here we've got 4 and p on both of these. So 4p factors out, leaves you with y minus k. All right, so we can divide both sides by 4p. Gets it out of here. And then finally we can just add k, since that's all that's left over there. So add k to both sides. I'll write it a bit neater. X minus h squared over 4p plus k equals y. So there's your formal definition for a parabola. HK, again, is your vertex. P is that opening pattern we messed around with earlier in the year. So if you want to compare it back to A, because before we just defined it as A times x minus h squared plus k. We actually did that formally earlier in the year. So if you want to think about what A is, the value out in front, it's 1 over 4p. So A affects the opening pattern. 1 over 4p tells you p is that distance from the vertex to the focus and to the directrix. So let me flash back up to show you that. So anyway, that's how we use that leading coefficient at A that's out front to define what this distance is right here and here. Now we've done all the preliminary work, let's go ahead and formalize all this stuff. So section 9, we want to continue to talk about parabolas this time. We did circles, and now parabolas are also in the same section. So what is a parabola? I asked you a similar question about a circle. Well, a parabola is all the points that are the same distance to a focus and a directrix. So let me uncover that. Just see that, all points same distance from a focus and the directrix. So first up, what we've already done, the equation for a vertical parabola. And that one is y equals x minus h squared all over 4p plus k. Now the book does have an alternate version of this where it has y minus k over here and times 4p, and I found a lot of students like that. If you do like that, that's fine, go with it. It really doesn't matter to me. I usually use this definition because it's really similar to what we've already done solving for y, but I'm fine either way. I don't care how you write it. If you write it the way the book does, I'm okay with that, and I'll accept it on any test or quiz. Now your focus, just sort of a quick little sketch. Your focus is up here, your directrix is down here. Here's h, k, and that distance is p, the direction you go. So the focus is going to be same value horizontally, so h, but it's going to be k plus p as you go up. The directrix, so the first time I've actually written that out for you, that's how you spell it. It's a horizontal line, so there is no x to worry about. It's just y equals, and it's going to be whatever your k value is for the vertex and p below that, so k minus p. Now we have encountered horizontal parabolas that are sideways. So the equation for that, and I'm not going to derive it, it's a really similar process. A few things are switched around, but here's what it would look like. It would be 8x equals y minus k squared over 4p plus h. It really just, the x and y switch here, k and y switch here, and then same deal, x and y or x and h gets replaced by k and y. So really same thing. That's your formal definition. The book also has this in an alternate way where it, let me go ahead and write that out. The book's alternate way to look at this, it'll have 4p times x minus h equals y minus k squared. So either way, I'm fine either way, it doesn't really matter, but that is another way you'll see it. All right, just to kind of make a little quick sketch here. It's sideways, the focus is inside the parabola, directrix is behind it. Still HK, and we're still looking to be P away for the focus and the directrix. So with the focus, this time you're changing the horizontal value, so it's H plus P, but your K value, your Y value is still going to be the same. Because you're not moving up or down to get to the focus. You're staying same amount up, same amount in the Y direction. Your directrix, you're going to move back, but it's a vertical line, so all you care about is what x equals. And that's going to be h minus p. So those are the formal definitions if you need them for focus and directrix. You'll probably be able to get these without really doing all the formalities, but there they are just in case. For this problem, it just says find the focus and directrix, but I'm going to go ahead and draw a little sketch also. So over here, I know that this is a vertical parabola because it's y equals. It opens up, and I'm going to find the a value in a moment because that's what we're used to, but it's a positive number right here, so this is going to open upward. The vertex is going to be at 3, -5, so down here. Let's find that a value. So a is going to be 1 over this number. So 4p is 8 in this case. And I don't want to make this too crazy. Usually most students are okay to just kind of think about it this way. If I want 4p to be 8, then p would have to be 2. You probably don't need to do much algebra to see that. But p equals 2, that's going to be handy when we find the focus and directrix. But really for now, a is just going to be 1 over 8. There's really not a whole lot to do with that. So that means every time I go right or left, I'm only going up 1/8, so I'm barely going up at all. The next time I go one more, I'm going to go up 3/8, so I'll be up to 1/2. So this thing is very slowly opening. Next time I would go 5/8, so I'll be just a little bit above -4 there. And I think that's good enough. I'm going to start with that. So my focus is going to be happening somewhere in this area. Directrix is somewhere down here. We don't have to worry about how far away right now. If you want to start using the p-value, you know it's 2 above, 2 below. But that's enough to kind of get us in the right direction. So to get the focus, well, we know the h coordinate is going to stay the same. So 3 is definitely part of that. Now we're going to take our k, which was -5, and we're going to scoot 2 up. So it'll be -3. Now for your directrix, it's just a horizontal line, so it's just y equals. And it's going to be the k value minus p. So that vertex k value is -5. Subtract 2 more, and you get -7.